This video goes over some more examples of the distributive property. So the first example asks us to simplify. Here we're just collecting like terms. So I'm going to underline my x's, and I'm going to put a box around my y's. I'm going to combine my x's first. 4x minus 2x is 2x. 3y plus 4y is 7y. In my next example, I have m and n, and I'm going to do the same thing. So my m's, I have minus 5, minus 12, so minus 17m, and then minus 7n plus 6n is minus 1n. Now let's do some more examples with expanding. 4 times 3a plus 2. Remember, when there's a number outside the brackets, it applies to both things inside the brackets. So 4 times 3a plus 4 times 2, which is 12a plus 8. Those terms are not like, I cannot simplify them. In example B, I have a negative 1. That applies to both things inside the brackets. Negative 1 times 2x. Negative 1 times negative 5 simplifies to minus 2x plus 5. Example C, I now have 3x outside the brackets. That applies to all three terms inside the brackets. So 6x cubed minus 9x squared minus 3x. And I'll add in one more row. If you are writing out each multiplication step, this is what your second line would look like, but you do not need to write that. Now we're going to go on to some more complicated examples here that have multiple sets of brackets in one expression. If you have multiple sets of brackets, the same rule is true. Whatever is immediately outside a bracket applies to both things inside the bracket. So here I would have 10a minus 15, and then my second set of brackets plus 12a plus 4. Now I'm going to notice that I have two terms that have an a and two terms that are numbers. I'm going to take the numerical coefficients in front of my a's and add them together to get 22a. And I'm going to take my numbers and add them together using my integer rules. Let's do another example, this time with a negative. So in my first example, I have 2 times x plus 2 times minus 4. My second set of brackets, I have negative 5 times 2x minus 5 times positive 5. So let's write this one out. So I'd have 2 times x plus 2 times minus 4 minus 5 times 2x minus 5 times 5. That minus 5 applies to both terms inside the brackets. When I complete my multiplication, I'm going to notice the same thing as before. I have two terms that have an x, and I have two terms that are just a number. In order to finish my solution, I can actually combine those together. So minus 8x minus 33. Let's try another example with some more variables. So I have a 3 outside of these first set of brackets. That 3 is going to apply to each term inside the brackets. Same with the minus 4 in my second set of brackets. Multiplying those out, I've got 3 times minus 4a plus 3 times minus 2b plus 3 times 3c minus 4 times a minus 4 times 3b, and finally minus 4 times minus 5c. So 12a minus 6b plus 9c minus 4a minus 12b plus 20c. I'm going to notice that I have two terms that have an a, two terms that have a b, and then two terms that have a c. So I can combine those together using like terms. 12a minus 4a is 8a. Minus 6b minus 12b is minus 18b. 9c plus 20c is plus 29c. I don't have any more like terms, so that is as simple as my equation can get. Let's try example D. Now I've got three sets of brackets. My rules are still the same. Whatever is immediately outside of the bracket applies to everything inside the bracket. My first bracket, I would have 10m squared minus 15 plus 12m squared plus 40 minus 6m squared plus 5. My next step is going to be to collect like terms. So I'm going to notice I have three terms with m squared, and then I've got three terms with numbers. So 10m squared plus 12m squared would be 22m squared, minus 6 would be 16m squared, and then I have minus 15 plus 40 plus 5, which would be minus 10 plus 40, so plus 30 as my final answer. Let's try another example. This one only has one set of brackets, so I can expand by applying that 4 to just those two terms that are inside the brackets. Once I've done that, I'm going to look and see if I have any like terms. I have 2m squared, 4m squared, and then I have minus 12m and plus 11m. I can simplify this to 6m squared minus m. Those terms are not like because their exponent is not the same, so I cannot combine them. Next example, 3x times 2x plus 3x times 3 minus 2x times 4x minus 2x minus 3. Here we would get 6x squared plus 9x minus 8x squared plus 6x. Now I'm going to look for my like terms. I have two terms with x squared, and I have two terms with just x. Then I can combine them together. So minus 2x squared plus 15x. Last two examples for this type. G is sort of tricky because there are brackets, but there's actually nothing really to distribute because the number in front of both of these brackets is positive 1. What I can do is I can just rewrite that expression without the brackets. Now I can identify my like terms and collect them to simplify my expression. H, however, has a minus in between the brackets, so it is important to make sure that that term is distributed into the second bracket. In front of my first bracket, I only have the number positive 1, so I can just rewrite those two terms without the brackets. My second two terms are going to be minus 4m plus 18. Now I can look for my like terms, and I can collect them to simplify my expression. 6m minus 4m is 2m, and minus 7 plus 18 would be positive 11. The last type of example that we're going to do is a question that asks you to simplify and then evaluate. So in order to simplify, what that means is we're going to get rid of the brackets. By distributing, negative 5 inside those two terms. So minus 10x plus 15. And then I'm going to connect my numbers because those are my only two like terms. And now I have a simplified expression. So simplified here. My next step is going to be to substitute. So I'm going to take x equals 5. And I am going to replace that where I have an x in my equation. So right here beside the 10. Now I'm going to evaluate that expression. So I get minus 50 plus 27. And let's see, minus 50 plus 27 is going to give me minus 23. This is my expression that has been evaluated. So 2 steps to this one. Let's take a look at B. We're going to expand by distributing the negative. I'm going to collect like terms. So plus x squared minus x squared is actually 0, so those ones cancel out. And I'm just left with minus 3x. Now I'm going to substitute x equals 5. Once I have that information, now I can evaluate my expression. Those are some more examples of the distributive property.